In section 10.2, we're going to go on to patterns and inductive reasoning. So we're actually going to do the solvent problem today. So I want you to do the solvent problem. You do not have to write the actual problem down, but any work or patterns that you may have with the solvent, please do write that down on page 599. Fold a piece of paper in half. When you unfold it, the paper is divided into two rectangles. Refold the paper and then fold it in half again. When you unfold it, there are 4 rectangles. How many rectangles would you get if you folded a piece of paper in half 8 times? I want you to figure this out yourself, so pause the video and figure this out. Now what you should have done, or maybe you did, is either folded a paper or you developed a pattern. So if you folded a paper the first time, you got 2 rectangles. After that, you got 4. If you folded it a third time, you would get 8. You will quickly notice that the pattern shows that it doubles after each fold. So the next time would have been 16, and then 32, and the pattern would continue on. The 8th time, after 8 times, after you folded it, you would get what? You would get 256. So now I want you to look at the gray box in the middle of page 599. It says, in the solvent, you may have used inductive reasoning. Vocab word. Inductive reasoning is based on patterns that you observe. So your essential understanding is that you can observe patterns in some number sequences and some sequences of geometric figures to discover a relationship. So on page 599 in problem 1, it says finding and using a pattern. Under the got it problem, we have 2 different parts, A and B. In A, we are given the numbers 45, 40, 35, 30. We want to find the next 2 terms in the sequence. Well, the next 2 terms in the sequence, obviously our sequence is decreasing by 5, would be 25 and 20. Now that's a pretty easy one. In part B, we have a geometric pattern, which roughly looks like that. So what would the next 2 terms in the sequence look like? Well, we know they're going to be rectangles. Make these a little bigger. Now we know we're going to have the one before it. Now you'll notice we connected all the midpoints. And then we connected the midpoints. And so then we're going to have to connect the midpoints again. So our next shape, we just keep going. Connect the midpoints, connect the midpoints, connect the midpoints, connect the midpoints. And so we're going to be left with like a square or a rectangle in the middle. So if we continue on, we keep going inside with the shape, connecting the midpoints each time. In the gray box on page 600, it says that you may want to find the 10th or 100th term in the sequence. In this case, rather than finding every previous term, you can look for a pattern and make a conjecture. Vocab word. A conjecture is a conclusion you reach using your inductive reasoning. So let's do an example of this. You don't need to write this down, and it's not in your book, but I want you to look at this shape first, or on all these diagrams, and then figure out what conjecture can you make about the number of regions 20 diameters form. So we want to know what 20 diameters will give us. So that's what we need to figure out. So you have to start finding a pattern. So in this problem, we see the first one has 1 diameter. 1 diameter gives us 2 regions. 2 diameters give us 4 regions. 3 diameters give us 6 regions. So what is our conclusion here? Well, we know that each circle has twice as many regions as diameters. So if you have 20 diameters, you're going to take 20 times 2, and that's going to give us 40 regions. So you have just used inductive reasoning to make a conjecture. So if we look at the got it problem, it says, what conjecture can you make about the 21st term in the pattern RWB, RWB? And then we keep going. So what can we make? Well, here's what we got to look at. You could go to 21 terms. But our 21st term, if you notice our pattern, it happens every 3. So that means 3 goes into our 21st term. So we want to know the third term is B. So if this continued 7 more times, 7 times 3 is 21. 7 times, we're always looking at the last letter in our sequence. And so that would be our 21st term. So our 21st term would be B. So our answer for our got it is B. Let's look at example 3. Use the sequence and inductive reasoning to make a conjecture. What is the color of the 30th figure? Well, 30, we could look at it different ways. We could look at every 5th term, every 6th term, every 3rd term. So we just kind of have to look and kind of figure out what's going to happen here. So we see that, okay, the first term, that doesn't really help us. The second term doesn't. But the 30th term, this goes in patterns of 3, and that's what we want to look at. It goes like pink, red, blue, pink, red, blue, pink, red, blue. So our 30th term, our pattern, happens in groups of 3. Since we're talking about our 30th term is a multiple of 3. It'd be 10 times. So it doesn't matter. Our 10th set of 3 is still going to be pink, red, blue. So our answer for 3 is going to be blue. At the bottom of the page, it says it is important to gather enough data before you make a conjecture. For example, you do not have enough information about the sequence 1, 3 to make a reasonable conjecture. The next term could be multiplying by 3, which would be 9, or adding 2, which would be 5. So we're going to look at problem 3 at the top of page 601. This is not in your book, but if you want to write this somewhere, you can. What conjecture can you make about the sum of the first 30 even numbers? So the first thing you got to do is you got to find a pattern. So we actually have to figure stuff out. So I'm just going to make a chart. This is going to be the number of terms. And since we're talking about the sum, we have to take the sum of those terms. So if we have one term, well, that's 2. So this would be just 2. If we had 2 terms would be 2 plus 4. That gives us 6. If we had 3 terms, that's 2 plus 4 plus 6. We're adding even numbers. That gives us 12. 4 terms, 2 plus 4 plus 6 plus 8. That gives us 20. So you have to look for a pattern. Pause the video, look for a pattern. Here's where you probably started. You probably looked and said 2 to 6 is plus 4. This is plus 6. This is plus 8. Since they're not the same number, that really doesn't help us. So here's what we're going to do. This is a little tricky. How do you get 2? 2 times 1. Or we can say 1 times 2. How do we get 6? We can get 6 by taking 2 times 3. How do we get 12? Well, we can take 3 times 4. How do we get 20? We could take 4 times 5. So I want you to pause the video and see if you can see a pattern now. You'll notice that each sum is the product of the number of terms and the number plus 1. Take this number, we times it by 2. We take this number, times it by 3. We take this number, times it by 4. We take this number and times it by 5. So What is the sum of all 30 even numbers? Well, the 30th term would be 30 times 31, which will give us 930. So let's try the got it. Sum of the first odd numbers, 30 odd numbers. So we have 1 term, 2 terms, 3 terms, 4 terms. So the first odd number is just 1. That's going to give us a sum of 1. 2 odd numbers added together, that's going to give us 4. 3 odd numbers, 9. 4 odd numbers would give us 16. Look at the pattern. 1 to 1, 2 to 4, 3 to 9, 4 to 16. What is your conjecture? Well, you know that the sum is just the square of the number of terms. So if we had 30 terms, you would just take 30 squared, and the sum of them would be 900. In problem 4, we're going to talk about making a prediction. So in the got it problem, I want you to look at the backpack sold graph on the right side of the page. It says, use the graph of the sales information from problem 4, which is that graph. What conjecture can you make about backpack sales in June? Well, you notice it starts at November. What happens from November to December? December to January. January to February. February to March. March. You'll notice that the pattern is approximating, it's approximately going down 500 backpacks per month. So, what conjecture can you make about backpack sales in June? Well, if they're approximately, you could look at, say, 80, let's see, March, April, May. May could be about 8,000. So if you say 8,000 for May, June, about 500 less, could be about approximately 7,500 backpacks. Now, once again, this is just a prediction. B. Is it reasonable to use this graph to make a conjecture about sales in August? Think about this. Backpacks in August. Your answer is going to be no. Because sales are going to increase because students may want backpacks for school. Back to school shopping, people are going to want backpacks. So this would not be a good graph to determine August sales of backpacks. In problem 5, we're going to start by finding a counterexample. Above problem 5, it says, in the gray region, not all conjectures turn out to be true. You should test your conjecture multiple times. You can prove that a conjecture is false by finding one counterexample. Vocab word. A counterexample is an example that shows that the conjecture is incorrect. Make sure, though, that you understand that even though one counterexample can prove a conjecture false, no number of examples can ever prove a conjecture true. So let's start with a got it. So the first one, A, if a flower is red, it is a rose. We have to make a counterexample. So, counterexample, we're going to first state something that's red. A carnation is red. But then we have to say, our carnation is red, but it is not a rose. There is our counterexample. B, one and only one plane exists through any 3 points. Well, we can say when 3 points are collinear, that's a vocab word. Remember, that's when they lie on the same plane, or lie on the same line. The number of planes I'm going to abbreviate. The number of planes that can be drawn through them is infinite. C. When you multiply a number by 3, the product is 6. I'm sorry, the product is divisible by 6. So I'm going to say you multiply 5 by 3. Well, the product, which is 15, is not divisible by 6. A counterexample can be kind of fun. You're just proving things that are not true. So our 3 vocab words from section 10.2 are inductive reasoning, conjecture, and counterexample.